I'm gonna start this with a request, Rajiv. Next time, let's make this in the beginning of the week, because this has taken the best of me. So tired, so tired. Hey, for those of you that do not know me, as Rajiv said, I'm the co-founder of Consensus Diligence, and I've been doing this for the past 5 years. And by this, I mean providing services of offensive security in the Web3 space, more specifically on Ethereum, and getting more and more involved with Solidity and EVM, both at the compiler level and at an EIP level. And thinking about how I could help all the people that are now starting to get into the space and all the education efforts that Securium has going on, I thought the best way to do that would be to give concrete advice. So we're gonna start a little bit abstract, but we're gonna zone in into what is hopefully very precise and cool advice if you're just starting to think about security, whether you're a developer or whether you want to be an auditor. So let's start with the fact that the EVM itself is very different from Solidity. And let's illustrate this with an example. I don't know if you guys can see it from the audience, and I also don't know if you guys are prepared to do security this early, but does anyone want to take a jab at what is wrong here? By the way, this code base is from Gnosis Safe Zodiac new scope card. So this was a bug that I found late last year that actually got me thinking about the exact thing that we're gonna talk about here today, right? Which is the differences and mismatches of things that look similar. The ways your brain tricks you into thinking that some things have fuzzy boundaries. So I'll go ahead. This is not a very obvious one. What is happening here is that the Zodiac team, while writing this code, made an assumption about the first 4 bytes of call data, right? What you're seeing here is the scope card is a function that actually, as the name indicates, guards the scope of what can be accessed by certain transactions going out of the multisig, and so it permissions based on function IDs, right? Based on function signatures. Function signatures and function IDs are basically just like the cat-check hash of the canonical types of a function. You take the cat-check hash, reduce it to the first 4 bytes, and that gives you the identifier to get to a certain function within a smart contract, right? When they were writing this code, they assumed that either your call data has more than 4 bytes, and then you go into a list and see whether those 4 bytes are permitted, are within the scope, or you have less than 4 bytes, and therefore your call data is going to be 0, and so it's permissioned by the fallback function. And this is, oh, did we lose the slides? No. Oh, I have to keep clicking my, sorry guys. No. We're on, sorry. And this is a very good representation exactly of how these fuzzy lines might get you into trouble, right? The fact is that jump tables and the ABI are not an EVM construct. It's fine, we'll keep going. The fact is that jump tables and the ABI are not an EVM construct, right? And so what happened here is that they forgot that if you send less than 4 bytes of call data, the EVM still extends that space with zeros if you try to access longer. What this means is that if I have a function ID that ends zero byte, then it'll actually fall on the fallback function case, and therefore I could access other contracts functions that were not within scope just because the fallback function was a permitted function for that contract. And we're gonna zone in. This started off very abstract, right? But what this is, in its essence, is a mismatch. Other examples of mismatches between the EVM and Solidity, other examples of like fuzzy lines are, for example, the storage model and types, right? Newcomers, new developers might think that the storage model is something that is native, something that Ethereum itself has, but it's not. Solidity actually created an addressable space out of mappings and Ketchak hashes and all of that, but none of these things are really native. You know, Solidity has its own way of handling it, but this is down to the compiler. And this is the trying to get this into precise advice. Vulnerabilities pretty much exist as mismatches. If you are trying to think about how to secure stuff or how to find problems within code bases, you have to look for mismatches, these types of mismatches, where does the EVM end, where does Solidity begin, right? And these mismatches present themselves in business logic as well, not only in code-related bugs or the execution environment boundaries. And I made a nice graphic for you guys to enjoy. Vulnerabilities are exactly the thing that sticks in between differences of the specification and the implementation, if we're talking about business logic, right? That's what an auditor does, really. So you have a certain expectation of how your code should behave, and then you implement it slightly different, and there comes an attacker and finds space in between these two boundaries to come and wreck it all, steal all your money. A good example of this is that safe transfer does not work the same way for ERC20 and ERC721. Right? If you think about it, one of them has a callback, one of them might include reentrancy issues. Reentrancy by itself is not bad, but one of them might cause reentrancy issues. The other definitely does not. But from the outside, for someone that is, again, a newcomer, for someone that is like not yet, hasn't yet found where these boundaries lie, this might create space for attackers. Again, your job as an auditor is literally identifying the boundaries first, and that's also part of like gaining knowledge. You should read docs, you should inform yourself, and then finding the vulnerabilities in the fringes. And I'll end this with what is hopefully actionable advice. I think that if you start auditing or reviewing your code as a developer, doesn't need to be specific advice for auditors, but if you're reviewing any piece of code, the moment you hear your mind say something different, a different concept, and in the event of safe transfer, if you're talking to your colleagues and they're like, oh, but we're gonna use this with ERC721, your mind should light up and go back to the code and think, oh, this might throw everything into shit. Let me just reassess. That is the fringe. And I'll end this with another thing. Again, for new auditors, for all the people coming out of Securium, feel free to go. This is a link. I distributed the presentation on Twitter, but happy to distribute the links afterwards somehow. Go read about why security is really, really hard. It's very, very rewarding as well, but go read about why it's hard first. And that is all, guys. Thank you for listening.
Any questions for Gonzalo?
I can tell you about being an auditor. I guess this is a very non-contentious topic. It's fine.
All right.
Where they just
Let me
what?
repeat the question. Do you know examples from other languages where Viper, like other languages, smart contract languages, like Viper, and I don't know what else is there, but these things happen?
Oh yeah, absolutely. It'll happen in all languages. And that problem specifically has to do with the ABI, right? So it's a standard that is like, it's literally how contracts interact with each other. So Viper abides to that as well. I do not know specifically like about the jump table implementation in Viper contracts. So I wouldn't be capable of telling you whether this specific problem would surface in a Viper contract. I guess it would. But at the very end of the day, this will happen in any execution environment with any language, any compiler. You know, it doesn't need to specifically be about Web3. We just made the examples about Web3 because, you know, dogfooding. But this will happen anywhere, right? The mindset that you need to know what is exactly happening below in order to reason about the higher level and in order to reason about source code is applicable to pretty much anything. Hacker mindset.
Right, we have second question. I think the first one is the trickiest.
Mind yourself.
So what's like the set of steps that you usually go through when you start auditing a contract or a set of smart contracts?
Yeah.
The instructions.
Trying to keep it, like, again, generalizable and not down to what we do at diligence. I would say that like when you start doing these things, you go from the general to the specific, right? I'll first look at the entire code, build all the visualizations, stuff that helps me mentally map exactly what the code is doing, and then start reading the specific things, start going like modularly from function to function, like functionally. So like the visualizations are also good to reason about the way a program is working. So basically like general to specific, and start following down some rabbit holes about things that look like hotspots. Again, like I think tools play a big role in aiding with the visualization and understanding of systems, and then comes the human brain and the manual part, and we just like go again down the rabbit hole. Yeah. Yeah, I'll repeat the question. So the question is whether we work closely with the Ethereum Foundation, and more specifically the Solidity team, because we see so many contracts today. So yes, and this says, I think I was first involved with Solidity, and then diligence happened. So that is definitely a thing, and we keep talking to the Solidity team because like the sheer amount of examples of code bases that we see are actually relevant information for there to shape the language going forward. At diligence specifically, one of our ex-Dilly members called Steve Marks even created a mock language. So we actually built a compiler with all the security features that we would like to see imbued into Solidity, and they ended up picking up one or two. So yeah, very, very active. Well, as much as time permits, you know? Like, at the end of the day, we still do audits, but time permitting, yes, we like to be as involved as possible in shaping Solidity's future. And I'm going to do a shout out. This year's Underhanded Solidity contest had very little submissions, guys. So next year, if you get into it, you should definitely submit an entry to the contest. Okay.
Any more questions for Gonzalo? All right. Thank you, Gonzalo, for the wonderful talk.
Thank you, guys.